Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss half wave rectifier. Let's begin. Rectifier is a process through which we convert alternating current into direct current. Here, half wave rectifier, that is an electronic device which conducts current during positive half cycles of input AC voltage, which conducts current during positive half cycles of input AC voltage. In AC voltage, one half is positive, another half is negative. As we discuss about rectification, means conversion of AC into DC. So, in case of AC, only the positive halves are rectified. Therefore, its name as half wave rectifier. Construction of a half wave rectifier. We apply an AC source. In order to apply AC source, let we prefer a transformer. The primary coil that one be the secondary coil, we provide an AC input primary coil, secondary coil in the transformer T. That secondary coil is connected to the semiconductor diode D and with the load resistance RL in series. A, B, we apply the voltage input Vi to that end and we obtain the voltage output across that of load resistance. Here we use a PN junction diode, that is the symbol of PN junction diode. The arrowhead represents P type semiconductor and that bar represents the N type semiconductor. Why we use PN junction diode? In the study of PN junction diode or semiconductor diode, we discuss when it is under forward biased, means P type is connected to positive terminal and N type is connected to negative terminal. At that of situation, it conducts current throughout that of junction current flow. But in case of reverse biased, means when P type is connected to negative terminal and N type is connected to positive terminal, that is the reverse biased situation. In that of reverse biased situation, that semiconductor diode does not conduct current, means it restricts the flow of current. Therefore, the semiconductor diode is used in order to rectification purpose. Here we take AC input and a step up transformer is used, that is the voltage input, diode, load resistance are connected series with the secondary coil of that transformer. Working as we provide SC input. So, SC, we plotting the graph, that is the voltage, that be the current, the input voltage VI, here is the SC. So, SC source, one half is positive, another half is negative. During positive half cycle of input AC voltage, end A of the secondary coil becomes positive with respect to that end B. Therefore, the arrowhead of the diode becomes positive with respect to that of bar. That arrowhead now positive and that bar becomes negative. Hence, the diode becomes forward biased and it conducts current. As I previously said, when that junction diode is forward biased, at that of situation it conducts current. Now, during positive half cycle, A is positive, B is negative. Therefore, in that of diode situation, that arrowhead becomes positive with respect to that of bar and it is in forward bias situation and it conducts current. Similarly, in case of negative half cycle of input AC voltage, that end A of the secondary coils becomes negative with respect to that end B and the arrowhead of the diode becomes negative with respect to that of bar. Hence, the diode become reverse biased and it does not conduct current. In negative half cycle, A becomes negative, B becomes positive. So, that diode arrowhead becomes negative and that bar becomes positive. It is in the reverse bias situation and it does not conduct current. Therefore, the diode conducts during positive half cycle of the input AC voltage only. The diode is blocked during negative half cycle of that of input AC voltage. In this way, the current flows through that of load RL along one direction, the direction D RL B direction, and the output DC is obtained across that of load resistance. The current direction the direction of flow of current D RL B, and the output voltage the V output we obtain only positive half cycles. Here is the time. Input AC and we obtain the output DC, that is rectified. That type of rectification is known as half wave rectification. That device is known as half wave rectifier, since only positive half cycles are rectified. Next, some technical terms related to half wave rectifier. Rectification efficiency. Rectification efficiency of a half wave rectifier is defined as the ratio between output DC power to input AC power. Here we obtain DC as we input AC. So, the ratio of output to input is the efficiency. Here output is power of DC, input is the power of AC. Now, we have to calculate what is power of DC and power of AC. The output DC power is given by P of DC is equal to I DC square load resistance R of L, means P is equal to VI, voltage into current. Instead of voltage, that is V is equal to IR, therefore I square R, where IDC average value or the DC value of current, DC value of current. Equation number 2. Now, we calculate what is average value or DC value of current. The average value of current for a half wave rectifier is given as I of DC is equal to 1 by 2 pi, that is integration over I d theta, that theta from 0 to pi, where I, that is the instantaneous current. And the instantaneous current is put it 1 by 2 pi 0 to pi, that is I m sin omega t d theta, where I is equal to I m sin omega t. Instantaneous current is the peak current, sign of that value. Here I m, that is voltage, maximum voltage V m, to that of net resistance R f plus R L. R f, that is forward resistance, R L is the load resistance of that of diode. That I m, which is called the peak value of current, peak value of current where omega angular frequency, T be the time, Vm peak value of voltage, Rf forward resistance of diode, RL we have already known, that is the load resistance. Now theta, again we put theta is equal to omega t. That equation is written as 1 by 2 pi integration over 0 to pi Im sin theta d theta is equal to Im divided by 2 pi integration over 0 to pi sin theta d theta, integration over sin theta Im divided by 2 pi as minus cos theta, then limit from 0 to pi equal to Im divided by 2 pi upper limit minus lower limit, upper limit cos pi minus, that is 1 cos 0, 1 plus 1 2 Im divided by 2 pi into 2. Finally we obtain I of dc is equal to Im divided by pi, and that value of Im of dc now put it in equation number 2. Therefore equation 2 becomes power of dc is equal to, as we know, I dc square RL. Therefore power of dc I dc Im divided by pi square into RL, or power of dc is equal to Im square RL divided by pi square. Equation number 4. This is power of dc. Again our requirement is power of SC. Now the input AC power, the input AC power is given by P of AC is equal to I RMS square, root mean square, RF plus RL. Equation number 5, where IRMS that is the root mean square value of current, Let we calculate what is the value of IRMS in case of half wave rectifier. The root mean square value of current for a half wave rectifier is I RMS is equal to 1 by 2 pi integration over 0 to pi I square d theta, its under root. IRMS square is equal to that much. So IRMS is equal to under root of that particular term, 1 by 2 pi integration over 0 to pi value of instantaneous current as Im square sin square theta d theta, its under root is equal to Im square to outside, Im square divided by 2 pi integration over 0 to pi sin square theta d theta, its under root is equal to Im square divided by 2 pi integration over 0 to pi sin square theta in terms of 2 theta as 1 minus cos 2 theta divided by 2, its under root is equal to Im square divided by 2 pi, its integral, that integral can be solved as half d theta is equal to theta by 2 minus cos 2 theta by 2 cos 2 theta by 2 integration. So it is sin 2 theta divided by 4. Use the upper limit, lower limit 0, under root is equal to Im square divided by 2 pi, upper limit minus lower limit, the final result, that is pi by 2 under root, which is equal to I, here pi cancel out, 2 to 4, so Im square divided by 4 under root. Finally the value of IRMS is equal to Im divided by 2. We can put the value of IRMS in equation number 5. Therefore equation number 5 becomes power of AC is equal to Im square Rf plus RL divided by 4. Now we can put the value of power of AC and power of DC in equation number 1 as the efficiency, rectification efficiency. Equation number 1, equation 1 becomes efficiency ta is equal to Im square RL divided by pi square whole divided by Im square Rf plus RL divided by 4. Is equal to Im square RL divided by pi square into 4 divided by Im square Rf plus RL is equal to 4 by pi square Rf divided by Rf plus RL. Four by pi square, that value around 0.406 into RL divided by Rf plus RL. RL divide both numerator and denominator side, So, we obtain efficiency eta is equal to 0.406, RL is divided, that one is RL by RL 1 plus RF by RL 1 plus RF divided by RL. That is the efficiency. Equation number 8. Look at that situation. If RF is very less than RL, then that efficiency is maximum. Therefore, we obtain eta maximum as 0.406, the maximum value, or in percentage it is eta maximum as 0.406 into 100%, which is equal to eta maximum as 40.6%. From that equation, we conclude that a half wave rectifier can convert a maximum of 40.6% of input AC power into output DC power. Hence, a half wave rectifier can convert a maximum of 40.6% of input AC into output DC power. (40.6% of input AC power into output DC power). Another technical term associated with half wave rectifier is peak inverse voltage. Peak inverse voltage. So, what is peak inverse voltage? It is defined as the maximum reverse voltage that a semiconductor diode can withstand without destroying the junction. That is peak inverse voltage. Here the maximum voltage across the secondary coil of the half wave rectifier is V of n. Therefore, the peak inverse voltage for half wave rectifier is equal to V of m. V of m, that is the maximum voltage across the secondary coil of the half wave rectifier. As we know, during negative half cycle of SC input voltage, the junction diode becomes reversed and it does not conduct current. means no current flow through that of load RL, and there will be no such voltage drop. As a result, the whole of the secondary voltage, which is V maximum Vm, appears across the junction diode. As we can say, the peak inverse voltage for half wave rectifier is equal to V of m. The half wave rectifier so many advantages and disadvantages. The advantages are, it is a simple circuit, it has low cost, it is easy to construct, it has low number of components. Disadvantages, it has low efficiency, it produces low output power, it has high ripple factor. So, ripple factor we discussed in upcoming videos. This is a technical term related to rectifier. Next, it is not suitable for power supply. Applications, it is used in switch mode power supply, that is SMPS, to rectify output voltage. It is used in battery chargers, used in EST, extra high tension section of CRT, cathode ray tube based color TV. It is used in soldering machines. It is used as a detector in an AM radio, amplitude modulator radio. It is used in pulse generator, used in firing circuits, used in signal demodulation in case of center tapped full wave rectifier. Full wave rectifier classified two categories, one is center tapped, another one is bridge full wave rectifier. So, in case of center tap, it acts as signal demodulation. So, here with the help of this video lecture, we understand the concept of half wave rectifier, construction, working, voltage input and output graph, one technical term, rectification efficiency. And rectification efficiency is calculated in percentage. Another technical term, peak inverse voltage. Some points to advantages, disadvantages and applications related to half wave rectifiers. So, with this useful and informative notes, let me wind up this session. Thank you.